Hey guys, once again welcome to our channel for Education Lab. As you can suggest by the video's thumbnail and title, the chapter that we are going to discuss today, we are going to explore today, will be concerned with physical chemistry. So without wasting our precious time, let's just dive in. All right. So the first concept that we're going to start off with in today's video will be concerned with atomic structure. So, first thing, we should know what are the particles in the atom and what is the structure of the atom. This is very important thing when you are dealing with AS level chemistry. Um, in this chapter, we will be working according to the syllabus. Okay, let me just show you the syllabus first. It will be good enough. 1 second. Let me just go into the syllabus. Yeah, it's here. So you can see clearly here. Should I? Okay. This is our AS level, CIE AS level syllabus. The code of the subject is 9701, and you can see here we'll be dealing with each concept according to the syllabus. And the first concept is about concerned with atomic structure, and that is 1.1 particles in the atom and atomic radius. Okay, so these are the sub concepts that we're going to discuss in today's video and in future videos as well. So you can see here all the concepts one by one. Understand that atoms are mostly empty space surrounding a very small dense nucleus that contains protons and neutrons. Electrons are found in shells in the empty space around the nucleus. So this will be our first thing that we're going to discuss. We're going to start off with. All right. So let's see. Now, particles in the atom and atomic structure. Now, let's see what is the structure of an atom. Now you can see here all matter is composed of atoms, so here the smallest parts of an element that can take place in chemical reactions. In this statement you can see clearly that we are also defining what is the atom, what atom is actually. Okay, so all matter, everything around you and yourself, even yourself, everything is composed of atoms, everything consists of atoms. And these, what are these atoms? These atoms are the smallest parts of an element that can take place in any sort of chemical reactions. And we will discuss that further in upcoming videos. Atoms are mostly made up of empty space around a very small dense nucleus that contains protons and neutrons. So what happens? In atoms, there is a mass concentrated in the middle of the atom. Atoms are mostly empty space, and that concentrated mass contains two things, protons and neutrons, and you will find that electrons are orbiting in shells around that nucleus. You will see the diagram also related to this. The nucleus has an overall positive charge. And why is it so? Because protons have a positive charge and the neutrons have a neutral charge. Okay, so the neutrons don't have a charge. In other words, you can say that neutrons actually do not have any charge. Protons have a positive charge, so overall charge of that nucleus will be positive. That's straightforward. Now, negatively charged electrons, you can see they are negatively charged and they're found in the orbitals in the empty space around the nucleus. We'll also discuss the structure of these orbitals, but this is the basic info that you should be aware of when dealing with the structure of an atom. Electrons are negatively charged and they are orbiting in the empty space around the nucleus. So let's have a look at the structure now. So you can see here, you can see that here we have mostly empty space. Let me just highlight it to make it clear. Um, okay, so here you can see around the nucleus there's mostly empty space. And the nucleus, you have two subatomic particles that are proton and neutron. The green one represents the proton and the blue ones represent the neutron. All right. And you can see these are the orbits. these circles you can see, these electrons are just moving randomly inside these orbits. All right, so I think this should be clear. The basic information should be clear with all of you. So let's move on to the next slide. All right, let's see. Now, subatomic particles. Now we will discuss these subatomic particles, protons, neutrons, and electrons in further detail. Let's see. Now the protons, neutrons, and electrons. One second, guys. Now the protons, neutrons, and electrons that we already just saw in the previous slide in the diagram. The protons, neutrons, and electrons that an atom is made up of are called subatomic particles. So these are given a name. Collectively, they are given a name, that is subatomic particles. One second. Some problem is there. One second. Yeah. Now, these subatomic particles are so small that it's not possible to measure their masses and charges using conventional units such as grams or coulombs. So you can say that these units, grams and coulombs, are too big, are two huge units, enormous units, that you cannot measure these subatomic particles using these units. So they have different units, and these different units are called conventional units. All right. Now you can see instead their masses and charges are compared to each other. So you can say they are measured relative to each other. And what are these called? Relative atomic masses. Okay. And relative atomic charges, both masses and charges. They are compared relative to each other. Now, if you see in the next point, you'll see that these are not actual charges and masses, but charges and masses of particles relative to each other. Okay, so we are not looking into the actual charges and masses, but these are the charges and masses of these subatomic particles that are compared to each other. Now you can see that protons and neutrons have a very similar mass. Okay, so you will as actually this is not the actual mass. One is not the actual mass, but this is the relative mass. Relatively comparing to each other, we have assigned it a mass, and that the value of that mass will be 1. Electrons are 1836 times smaller than a proton and neutron, and so their mass will be also described as negligible compared to protons and neutrons. So with that, you can think of the structure of electrons, that how small, how tiny are they? And protons and neutrons, they have a very similar mass. So you can see that mass of the atom is always concentrated in the nucleus, because nucleus consists of protons and neutrons. These are the mass holders. And you can see that electrons, because they are 1836 times smaller than proton and neutron, they are really small. And so they are orbiting, they are moving randomly, very fastly, very swiftly in the orbits surrounding the nucleus. Let's go further. The relative mass and charge of the subatomic particles are, you will see in this slide. So you can see here, these are the relative masses and charges of subatomic particles. We have here the three subatomic particles, proton, neutron, and electron, and you can see in this table, we have given them relative charge and relative mass. So relative charge, proton is positive, so it will be having +1. Its relative mass is also 1. Neutron, um, it does not have a charge, as we discussed in the previous slides, that it is a neutral particle, neutral subatomic particle, so it has 0 relative charge. And mass of proton and neutron are similar, so neutron is also assigned a mass of 1. Electron is negatively charged, we discussed it earlier, and it is assigned a relative charge of -1. And the relative mass of electron is 1 over 1836. We discussed it earlier, and it is very tiny compared to proton and neutron, and moves very swiftly, very fastly in the orbitals surrounding the nucleus. Let's go further. Now, exam tip. Now we already saw from the table how the relative mass of an electron is almost negligible because it is really small. The charge of a single electron is minus 1.602 times 10 to the power minus 19 coulombs. Now don't just hassle here. Don't just hassle here because this is the exact the relative charge, you can say. Okay, this is the exact charge, minus 1.060 times 10 602 times 10 to the power minus 19 coulombs, whereas the charge of the proton is plus 1.60 times 10 to the power minus 19 coulombs. But these are the actual charges. Okay, and when we are measuring these charges relative to each other, relative to proton and neutron, we will say that their charges are minus 1 and plus 1 respectively. Okay, so these are the actual charges and these are the relative charges. Okay, so it's very straightforward. In this topic, in this concept, you don't have many hurdles here because it's a really simple topic, and physical chemistry is really a simple chapter. The chapters that we're going to discuss in our further videos, organic chemistry and organic chemistry, yeah, that's, you can say that is a bit of complication there. But yeah, with the help of these notes, with the help of understanding and explanation, we can understand these concepts really easily. So just don't worry about that. Now we will just stick to our concept, the concept that we are currently discussing. Let's move on further. All right. Now atoms, key terms. Some terms are important terms are there of related to atoms, concerned with the chapter of atoms, concept of atoms that we have to discuss here. Now, atomic number and mass number. Okay. Now, what is atomic number? Now, the atomic number, or you can say the proton number, is the number of protons present in the nucleus of an atom. Okay, is the number of how many, the count of protons present in the nucleus of an atom, and it has the symbol Z. Okay, now the atomic number is also equal to the number of electrons. Okay, so you can, from this line, from this statement, you can understand that whenever you are dealing with an atom, you will see that if you know the number of protons inside the nucleus of an atom, you will also know the number of electrons present in an atom. For example, if an atom has 3 protons, it will also have 3 electrons. If an atom has 5 electrons, it will also have 5 electrons, and so on. It goes. Okay, so the atomic number is also equal to the number of electrons present in a neutral atom of an element. So you need to assure that the atom is neutral. If the atom has a charge, if it's an ion, then it will have different number of protons and electrons. But that we'll be discussing in later videos. But for now, you should know that a neutral atom will always have equal number of protons and electrons. A neutral atom has no charge. Okay. Now, example, the atomic number of lithium is 3. If you're dealing with the atom of lithium, not non it doesn't have any charge. It's a neutral atom of lithium, and it has atomic number 3. From this atomic number, we can deduce that how many protons and electrons it has, meaning that a neutral lithium atom has 3 protons and therefore also has 3 electrons. The term neutral means here it doesn't have any charge. If it has a charge, it becomes an ion. Let's go further. Coming to mass number, I hope that the concept of atomic number is clear with you guys. It's a really simple concepts. Yeah. So the mass number or nucleon number here is the total number of protons plus neutrons. The atomic number was only the number of protons. Okay. And the mass number here, or you can say nucleon number, is the total number of protons plus neutrons present inside the nucleus of an atom, and it has the symbol A. So questions related to these can come. And also I would like to discuss with you that in our further videos, we'll also be discussing the past paper questions, because past paper questions are really important to discuss whenever you are dealing with the CIE topics, the CIE subjects. All right. So we'll be discussing the past paper questions, and that will help us a lot in improving your grades. Let's go further. The number of neutrons can be calculated by. How we can calculate the number of neutrons? There's a formula for that. Let's go further. you can see here the number of neutrons will be the mass number of that neutral atom minus the atomic number of that neutral atom. Protons and neutrons. So remember this formula because some past paper questions may ask you to calculate the number of neutrons of an atom, or they might ask you to calculate the mass number given the number of neutrons, atomic number. You may have to rearrange this equation, but that we'll be discussing later when we are dealing with those type of questions. Now, protons and neutrons are collectively they are called nucleons because they are found in the nucleus. Okay, so this may be a reason they ask you in the past paper questions why they are called nucleons. Okay, so you should know that. Now let's go to the next slide, and you can see here this is a representation of that. This is the exam tip for you guys, and you can see here the chemical symbol for the element is X. X could be represented by any element. It may be lithium, sodium, potassium, or neon, argon, anything, any neutral atom. Okay, and you can see that the atomic number, the proton number, or you can say, is always at the bottom of this chemical symbol element. You can see here subscript, superscript, superscripts, and subscript. That is a common word that we use to represent these. But you can see that atomic number is always at the bottom of the chemical symbol, and the mass number is always at the top. Number of nucleons in a nucleus. Nucleons means protons plus neutrons. So there's no need, it wouldn't create any confusion. So nucleons, whenever they're talking about nucleons, remember that they're always talking about protons and neutrons. That's the simple thing. Atomic number, proton number, that's the number of protons or the number of electrons in a nucleus. It's not collectively, but we are talking about only the number of protons or the neutrons. Okay, so here is an important point. The mass, nucleon, and atomic proton number are given for each element in the periodic table. If you open the periodic table, you will see that. Let me just show you guys. One second. In this. If I don't find, obviously it would be there, but let me just see here. Yeah, this is the periodic table. Actually, I have to rotate it a bit. One second. Yeah, so you can see here, for example, hydrogen, for sodium, let's say. Actually, it's not in a correct form, but they have given the atomic number here at the top and the mass number at the bottom. All right, but you need to know that the atomic number is always at the bottom and the mass number is always at the top. Just remember that. So I think we are done with the first concept that was concerned with the atomic structure. Let's just see that if we have covered all the points, which points we have covered and which points we have to cover in further videos. Let's see. Is the syllabus? Let me just go to the top. 1 second. Let me just rotate it again. Okay, okay. Let's see this. So we were discussing atomic structure. Which topic it was? Yeah. So we discussed this thing. Atoms are mostly empty space. Done. Identify and describe protons, neutrons, and atoms in terms of related charges and masses. Done. We discussed the terms atomic and proton number, mass, and nuclear number. Done. Distribution of mass and charge that we'll be discussing tomorrow. So in today's video, we have covered 3 points of the first concept 1.1 of physical chemistry. In our next video, we'll be discussing the concepts concerned with mass and charge distribution. So stay in tune for that video and for the upcoming videos as well. But make sure to subscribe the channel and hit that like button and the bell icon as well so you receive our videos ASAP. So that's the end. Take care and I'll meet you in the next video.